Calculus Appendix. In mathematics, you don't understand things, you just get used to them. John von Neumann. This appendix reviews the basic tools from calculus and mathematics that we use throughout this book. Superscript 1, which reads, Ethan Ligon is the co-author of this appendix. 2 additional advanced topics are on my Econ Lab. Returning to the text, it emphasizes unconstrained and constrained maximization. Section A1, Functions. A function associates each member of a set with a single member of another set. In this section, we first examine functions of a single variable and then discuss functions of several variables. Functions of a single variable. Suppose that we are interested in a variable x that is a member or an element of set capital X. For example, the set capital X may be the non-negative real numbers. A function f associates elements of the set capital X with elements of a set capital Y, which may be the same set as capital X. The function of f is a mapping from capital X to capital Y, which we denote by f colon capital X yields capital Y. The capital X is the domain of the function f, while capital Y is the range of the function. In applying the mapping from an element of capital X to capital Y, we write y equals f of x. We concentrate on real number functions. Frequently, these functions map from the set of real numbers, open parentheses, capital X equals outlined capital R, into the same set of real numbers, capital Y equals all real numbers. However, sometimes we consider functions with a domain that is an interval within the real numbers. For example, we might study a function that maps the numbers between 0 and 1. Such intervals are written as open bracket 0, 1 close bracket if the interval includes 0 and 1, or as open parentheses 0, 1 close parentheses if the endpoints of the interval are not included in the set. One can also use a parentheses and a bracket, writing open parentheses 0, 1 close bracket for the interval of real numbers that are strictly greater than 0 but less than or equal to 1. By writing that x is an element of open parentheses 0, 1 close bracket, we mean that the variable x can take on any value that is greater than 0 and less than or equal to 1. Some examples of functions of a single variable include, and there's 4 bullet points. first bullet point, identity function, f of x equals x for all x, an element of capital X. Second bullet point, zero function, f of x equals 0 for all x, element of capital X. Third bullet point, square root function, f of x equals the square root of x for all x greater than or equal to 0. Fourth bullet point, hyperbolic function, f of x equals 1 over x, which is not defined when x equals 0. These examples are called explicit functions because we can write them in the form y equals f of x. Some functions are implicit mappings between capital X and capital Y and are written in the form g of x and y equals 0. More concisely, in the form g open parentheses x comma space y close parentheses equals 0. For example, x squared plus y squared minus 1 equals 0 implicitly defines y in terms of x. We can always impress an explicit function f in implicit form by defining g of x and y equals y minus f of x. However, it is not possible to express every implicit function explicitly. For example, the implicit function g of x and y equals a times y to the power 5 plus b times y to the power 4 plus c times y to the power 3 plus d times y to the power 2 plus e times y plus x equals 0 cannot generally be rewritten so that y is a closed form expression of the variable x and the parameters a, b, c, d, and e.